Hello everyone, welcome back to Gilu once again. So in this video we'll be starting from question number 21 of exercise 5.1. So let's get started. In question number 21 we need to discuss the continuity of the following function. It has three parts as you can see, and one thing that you can see in common in the three parts are that sin x and cos x are both there, and the sin x and cos x are with different operators in the three parts. We know that if g and h are two continuous functions, then g plus h, g minus h, g dot h are also continuous. This we have learnt. So we'll be using this very property for all the three parts. So let us write it down. Now it has to be proved that g of x is equal to sin x and h of x is equal to cos x are continuous function, and that's how we'll be solving all the three parts. So basically what we will be doing now is proving that sin x and cos x are both continuous, although we know it to be so. So let gx is equal to sin x. Okay, now so therefore g of any real number c is equal to sin c. Now let us check the limit. Since it has no definition breakage, so it is constant throughout the domain. So let us find the limit at c. So limit of x tends to c sin x, it will be simply sin c. Therefore gx is continuous. Now similarly hx equal to cos x is also continuous with the same logic. Now since we have proved that both gx and h of x are continuous, so therefore gx plus h of x is continuous. Therefore sin x plus cos x is continuous. Sin x minus cos x is continuous, and sin x into cos x is continuous. Alright, so we have done the 21st question. It was very easy based on the information that we already know. Now coming to the next question. So in this problem we need to discuss the continuity of cosine, cosecant, secant and cotangent functions. That means cos of x, cosec of x, sec of x and cot of x. We need to find out this. So if you can see here, cosec x is basically 1 by sin of x, sec x is basically 1 by cos of x, and cot x is basically cos x by sin of x. So my point is, if I can find the continuity of cos x and sin x, I can easily comment on all of this, because we know that if g and h are two continuous functions, we know that, so h by g, where g of x not equal to 0 is continuous, 1 by g, where g of x not equal to 0 is continuous, and 1 by h, where h is not equal to 0 is continuous. Alright, so if anyway we can prove that sin x and cos x are continuous, then all will be very evident, all the proofs will be very smooth. So in the previous problem I already proved how you can show that actually any trigonometric function like sine or cosine is continuous. Once you prove that, you can conclude. So it can be concluded that cosec x equal to 1 by sin x, where sin x not equal to 0 is continuous. Okay, so then that implies cosec x where x not equal to n pi. Okay, because at x equal to n pi, where n is an integer, sin x is equal to 0. So cosec x where x not equal to n pi and n belongs to the set of integers is continuous. And very similarly, you can also prove the other ones like 1 by cos x and cos x by sin x. So I keep this to you. Alright, now I want to discuss one more thing. If this question is of 6 marks, maybe you need to show that sin x or cos x is continuous in a bit lengthy way. How can you do that? Please see here. So we will be proceeding from the very fundamentals. Let us prove that sin x is continuous. So we see that f of x is equal to sin x is defined for all x belongs to R. This is our starting statement. Then we shall write let c be a real number. Okay. Now put x equal to c plus h. Why? Because if x tends to c, then h tends to 0. Now if x tends to c and h tends to 0, we can write that g of c is equal to sin c. This we keep it because it will be later required to prove our continuity. Now we'll be doing limit of x tends to c g of x, that is equal to limit of x tends to c sin x. And if we replace this c by h, we'll be getting h tends to 0 sin of c plus h. Now it is just that we need to expand it. Sin c cos h plus cos c sin h. Now if h tends to 0, you can see that cos h tends to 1 and sin h tends to 0. So basically the result will be sin c, which is equal to g of c. So limit x tends to c g of x is equal to g of c. Now since limit of x tends to c g of x is equal to g of c as we found it, we can conclude that hence g of x is continuous. So if this is a bit lengthy, friends, so you have to show it in a bit elaborate manner, either sin c or cos c, or you can proceed to show both of them with the same steps. After you show that it is continuous, then you can use the properties to prove all of them. Alright, so I hope you have no problem. So let's keep it up to this today. We'll be meeting in the next set of questions in the next video. Thank you very much for watching this video.